candy. All right, so here we go. The day 5 of prereqs is to talk about using factoring to solve equations. So we want you to be able to use the ZPP. The second thing is just to know what the ZPP stands for, zero product property. You're going to use this zero product property a lot in Precalc, and you learned it last year. So I'm reviewing it for you today. And we're going to hopefully be good at solving equations by using quadratic formula if factoring won't work. All right, so the difference is, here's one, and they would just say factor. Go ahead, factor that one. That's on the test. But what's different for today is we will set it equal to something. We won't just factor it. You should be asking yourself, what should I break this into? Since there's nothing that goes into both of them, what should I break this into? Yes, ma'am. You have the answer, or you got a question? Okay, question. Yes. The stuff on that I just gave you the little quiz on, that was only part of what's on the test. The rest of what's on the test is factoring, which is kind of this part right here, and solving equations using factoring. So the only difference is, besides just factoring, today we are going to set this equal to 0. And then this whole thing will be equal to 0. So once you factor it, there's just one more step. All right. So how should you have factored it? You should have gone, oh, I know the square root of that. It's 5x and 5x. And I know the square root of 16. It's 4 and 4. And one's plus and one's minus. Raise your hand if you had that one right. Awesome. Okay, now, how do I take it to the next level? If I set it equal to 0, then that means either this has to equal 0 or that has to equal 0. Just think about it. Let's say I had A times B has to equal 0. Then do you get that either A has to be 0 or B has to be 0? One of them has to be 0. Okay, that's what we're doing with the zero product property. Product means multiply. And it means if you're multiplying and equaling 0, then either this is 0 or that's 0. So back to this. Either this is 0 or that's got to be 0. So you now write two separate equations and solve them. You say either 5x plus 4 has to equal 0, and you solve that little equation. That should be easy peasy. And over here, 5x minus 4 has to equal 0. That's two different equations that'll have two different answers. And why is there two answers? Because this equation is called a quadratic. And quadratics always had two answers. See, it has a little power of 2 there. All right, so then subtract 4, 5x equals negative 4, and then you divide by 5. Negative 4/5 is one of your answers. And you go back to this one. Add 4, 5x equals 4, and x equals 4/5. Negative 4/5 and 4/5 are my two answers. And that means if I actually put them in here, if I put in 4/5 and I square it, and then I multiply by 25, and then I subtract 16, it will equal 0. That's the point. I found the number x so that it'll make this equation equal 0. All right? So here's my two answers. If I were to graph it, it would look like this. Do you remember these guys? You remember how the two answers are the two spots where it hits? That's what you just found, is the two spots where it hits. Okay? All right, what if you can't factor it? Like, for instance, this, x squared minus 17. That's not going to factor nice. But if you remember what these look like, that's just a parabola that's moved down 17. Do you remember that? I set it equal to 0. If it's a parabola that's been moved down 17, it looks like this. There are two answers. I just don't know what they are. So if factoring won't work, then you use the quadratic formula. And so how do I do the quadratic formula again? X equals negative b. I like to say opposite b. So I'm going to start saying that this year. Anytime they say negative b, I'm going to say opposite of b. Because that's really what it is. Because what if b is negative? Then you're supposed to just use the negative, or are you supposed to use really the opposite of b? All right, x equals opposite b plus or minus square root b squared minus 4ac all over 2a. If you haven't memorized it, memorize it now. You have to use it on tomorrow's test. Quadratics are probably the #1 thing, the category of problems that you have to be able to handle. And I know you did a lot of quadratic stuff last year. You probably didn't use this formula too many times. You probably factored more. But this is a big one. All right, so how do I do it on this one? Well, in a normal quadratic, you have something like this. X squared plus 3x plus 5 equals 0. And that's A, the number in front, which is a 1. That's B, and that's C. Remember how that's A, B, and C? And those are the numbers that stick into the formula. Well, in this case, here, I don't have any B. That means B is equal to what? No, B isn't 1, otherwise I'd have a B in there. 0. B is 0. A is 1 in this, for this little equation then. A is 1. B doesn't exist, so B is 0, because if you go 0x, it would make it disappear, right? And then this is C. So C is negative 17. So I would go through and put in A is negative 1, so wherever I have an A, I would put negative 1. And then C is negative 17. C, negative 17. And then B, there is no, oh, B is 0, so I put a 0 here, and a 0 here. And then my answer would be x equals negative 0, or opposite 0, which is just 0, plus or minus the square root of 0 squared, which is 0, minus 4 times minus 1 times minus 17, all over 2 times negative 1, which makes negative 2. I'm getting close. I'm showing my work. I'm not trying to jump all the way to the answer. Yes, sir?
Why is A negative 1?
I screwed up. Sorry. A is just 1, and I saw my little equal sign there, and I thought it was a negative. Sorry. A is just 1. A is just 1. Sorry, erase the negative off in your notes. So then this is not negative 1, it's positive 1, and that's, thank you for catching that. And don't be afraid to say, Mr. Server, like if I'm got my back turned to you and you think I'm really missing something, just say, Mr. Server, with your hand up, and I will stop immediately and answer you. Thanks for catching that. Okay, so I'm now finishing off my quadratic formula dealy bob here. X equals, do I really need to say 0 plus or minus? No, I don't really need to say that. I can just say plus or minus the square root of negative 4 times 1 times negative 17. There's 2 negatives in there. It's going to make it positive. And 4 times 17 is 40. And then the 7 times 4 is 28. 68. Okay, square root of 68 all over 2. You'll have an answer like that on tomorrow's test. Yes, it's ugly. You don't know the square root of 68, but that's okay. Just leave it. It's actually kind of a blessing, because then you're done. If you can't figure out the square root in your head, like if it's square root of 49, you'd have to go farther because that's 7. But if it's a nasty one, you can leave it. Okay? So that's what you do if you can't factor it. You use the quadratic formula. Let me give you another one like that. You cannot factor this one. Yikes, but it might not have no normal answers. I'm going to make sure that it has normal answers. And I'm going to change that 4 then to 5. Yeah, that one will not factor, but it has normal answers. So, and I'm going to make this an X, even though it could be an A. That'll just confuse you. Okay. There is a typical problem that won't factor. So use the quadratic formula and figure out the answer for me. Yes?
If that has the equal 0,
If that didn't have the equal 0, you'd have to just stop and say prime. Done. But if it got the equals, then you got to go to the next step and figure out what is the answer. It's not just the factors. It's like x equals 6. We're looking for the answers here. Since this one will not factor, we go to x equals negative b, or opposite b, etc. There, I showed a little bit of work. Now I left the A, C blank because that's a lot of times where people make their mistakes. It's right there in this little part right here. So I encourage people to like put parentheses around the A and the C, because that's usually, if you screw this problem up, it's going to be underneath the square root that you'll screw up. Because everybody can do the opposite of a number, and everybody can multiply 2 times something. So if you're going to screw up, it's going to be under the root. So be careful in there. All right. So now, opposite of 3, or negative 3, plus or minus the square root of Let me see now. Negative 4 times 1 times negative 5. See how there's two negatives? See how that's going to turn into positive? We're not subtracting then. I'm going to do 9 plus whatever's that multiplies 2. And 4 times 1 times 5 makes 20. 9 plus 20 is 29. Square root of 29 all over 2. And like I said, that's kind of a blessing, because if that actually was like the square root of 36, we'd have to keep going and do it once with plus and once with minus and get two answers that way. But if it's a weird square root like that, done. Leave it like that. Raise your hand if you got that far. Good sign. Okay. All right. So the start of this hour, I was saying that if you have a problem that you can factor, just a second. Let me give you one that you can factor. There's one that's factorable. Factor that thing, set it equal to 0 like it already is, and then find me the two answers. Like once you got it down to two things, this has got an answer and that's got an answer. Make little equations. Pause while you work on that. Okay, here's what you should have done. You should have known that on this kind, you go 2x and x to start with, because the firsts, first, outside, inside, last, the firsts have to give you 2x squared, and that's how you get that. Next is, these two numbers have to multiply to 5. Well, it's not too hard to figure out. It's got to be 1 times 5. Then the only question is whether it's a 1 here and a 5 there or the other way around. Last logical thing is, these are coming out to a positive 5. That either means they're both negative or both positive. To get a middle term that's negative, they both have to be negative. Then you just check and you see if you get the right amount for the outside and the inside. That's the key to factoring, is the outside-inside thing. Outside-inside makes a total of negative 11x, so I did it right. Then I can say 2x minus 1 has to equal 0. X has to equal 1. No, wait, 2x has to equal 1. X has to equal 1/2. The other one, x minus 5 has to equal 0. X has to equal 5. 1/2 and 5. If you actually stick in a half and you square it, you got to put it here and here, it will work. It will give you an answer of 0. That's why these things are called the zeros. It's because when you stick them in the equation, you'll get 0. If you put a 5 in here and here, it'll work. It'll equal 0. All right, so there's your two answers. Raise your hand if you did that one right. Awesome. And there's only one other thing that you generally have to know, and that's that, what if they have it something like this? Equals 7. How on earth are you supposed to do that? Well, first things first. Always set the thing equal to 0. So we would move this 7 to the other side, or think of it as subtracting 7 from both sides. 2x minus 5 squared minus 7 equals 0. It has to be set equal to 0, every single problem. Now you can deal with the other junk, which is, this right here has to get all multiplied out, and maybe it'll factor. If it factors, you do it that way. If it doesn't factor, use quadratic formula. All right, so I'm going to multiply this puppy out. In what order should I do it? Is there an important order? Yes. Please excuse my appearance, Sally. Says the parentheses should be first. Can I actually do the x minus 5? No, there's nothing to do there, so I'm done with that. Can I do an exponent? Yes, so I got to do that next. If I multiplied by 2 first, it would be all wrong. You have to do it in the right order. That's what math is picky that way. 2 and then x minus 5 times itself. Do you get that this multiply right here has to come first because it was an exponent? Once that's done, I can multiply everything by 2. All right, so now I'm going to do this x squared outside inside to make minus 5, and minus 5 makes minus 10x. Lasts make plus 25. And now I'm going to multiply all that by 2. And then I still have a minus 7 equals 0. And now I'm going to multiply everything by 2. 2x squared minus 20x. 2 times the 25 still, we're doing that, plus 50. And then minus 7 equals 0. And then instead of rewriting this whole thing again, all I got to do is put the 50 and the minus 7 together. And that's going to make 43. And I would bet you that that does not factor. And by the way, if you ever just don't feel like factoring one, you can use the quadratic formula. It always works. That's the cool thing about the quadratic formula, is it'll always work. whether the thing factored or not. Factoring is usually easier than the quadratic formula, but if you can't factor it, use quadratic formula. If it's one of these kind where it's equaling 0, just use quadratic formula. X equals opposite of b, opposite 20, negative 20, which is 20, plus or minus square root of b squared, which is 400, 20 times 20, minus 4ac, a is 2, and c is 43, all over 2a, and 2a means 2 times 2, which is 4. And then I just, like I said before, almost all the mistakes are made right in there, so I'd be really careful with that part. And it probably isn't going to have a nice square root, so you'd be done as soon as you figure out what's in the red circle. Okay, so you're solving equations. This has two answers, because see, there's a plus answer, and then there's one where you do it with minus. If it doesn't factor, if it factors, life is so much easier. Just watch how fast you can get this. Do you get that this one right away? How do I make that equal 0? Can you just do it in your head? X has to equal 5. There's one of my answers. Now, could I set x minus 5 equal to 0? Yeah, that's probably the right way. But you're going to end up quickly coming out with x equals 5. Sorry. And then here's the other side. If it factors, it's so easy. You just solve simple little equations and you get the answer. There's one answer. There's the other. So if they factor, it is way easier than quadratic. But if you're stuck on factoring, quadratic formula always works. All right, that's the new stuff for today. And I'm about to hand out your worksheet. I'm going to pause for a second, see if there's any problems off that worksheet I want to do with you. Yeah, I am going to help a little bit on this worksheet. Number one says 25x squared minus 20x plus 4. The new thing for today is it's not just going to say factor, it's going to say solve, because it says equals 0. So now if I can factor it, that's awesome. Would it be smart to bang your head against this for 15 minutes trying to factor it? No, because there's another way that always works. What's the other way? Quadratic. So I'd just use the quadratic right off the bat. I'd be like, I don't want to factor that. That's going to be awful. Now maybe it isn't as bad as I think. Maybe it's just 5x. I'll give it a quick shot. 5x and 5x, because, you know, teachers kind of like symmetry, so it's probably like that. And then this 4 is probably 2 and 2. But if this doesn't come out right away, then I'm going to just give up. All right, what's that make? Negative 10x, what's that make? Negative 10x. Holy crap, I found it right away. See, that was pretty quick. Now it's going to be easy to do. So just try a quick factor, and if you can't factor it, you know, without lots of pain, do the quadratic formula. But you're going to have to square 20. You're going to have to do divided the whole thing by 50, so it would be kind of a pain to do the quadratic formula too. All right, so that was pretty quick factoring. 5x minus 2 equals 0. 5x equals 2. X equals 2/5. You get that? Other side over here, I'll do it in green. 5x minus 2 equals 0. 5x equals 2. X equals 2/5. Wait a minute. Didn't I just have that? Oh yeah, that's right, because this was like, this is two roots that are exactly the same. When did you ever have a double root? Do you remember that when you had the double root is when it went like this and it bounced off the thing? Do you remember that being called a double root? That's because the two roots are exactly the same as each other. Okay. So my answer is 5/2, but could I say it's, no, sorry, 2/5. And could I say it's 2/5 and 2/5? Well, that's kind of dumb. It's just 2/5. But is it a double root? Yep. All right, moving on. The problem with number 5, when you get to number 5, you'll say x squared minus 8x it's not set equal to 0. Then the first thing you should do, set it equal to 0. So get this to come over here by adding 15 to both sides. X squared minus 8x plus 15 equals 0. Now it's okay to try factoring. And then I'd go, okay, what makes a 15? 15 is 5 and 3, and does that make 8? Oh yeah, it does. 5 and a 3, and then it's easy from there. All right. One of the harder ones is like number 12, because number 12 is not set equal to 0. Number 12 says 2x plus 3 quantity squared equals 169. Right off the bat, I just changed that to a minus 169 equals 0. Now I got it set equal to 0. And then I'd FOIL this puppy out. Remember, it's 2x plus 3 times 2x plus 3. Don't fall into the trap of thinking it's 4x squared plus 9. It's not. You can't just take that squared and that squared. Squaring means times itself. And there's a reason it's 169, because that's the square root of something. So it's going to end up working out nice a little later, maybe. All right, and then I got, FOIL it out, 4x squared outside, inside, 6x and 6x means 12x. Last means plus 9. Minus 169 equals 0. Okay, I guess I'm not doing any more of your homework. Good luck. I'll look forward to seeing some of you in the morning if you want extra help. Have a great day.